Our next presenter is Dr. Kalev Kalemets. He is CEO and co-founder of the startup company Fermi Energia from Estonia. It's a company exploring the possibility to set up a small modular reactor of up to 1200 megawatts in Estonia. The building could start in 2030, and it's a very exciting project, and I'm very happy to see that Kalev is here with us and can present the latest news about this project. So please, Kalev, the floor is yours.
Hej på dag. That is all that I can in Swedish. Is my presentation visible now?
Yes, we can see.
Yeah, excellent. So yeah, we have a strong Swedish roots, so that Janne has been the teacher for Henry, Martti, Kaspar, and Merja, who have done their degrees in KTH, like most of you, as I know. And Estonian involvement in nuclear energy goes way back to the Lithuanian project, where Eesti Energia, the government-owned utility, was 1/3 stakeholder, and at that time the company was led by Sandor Liive, who is currently our chairman of the board, and he clearly recognized that in the Baltic countries we cannot have security of supply without nuclear power if we are aiming to reduce carbon emissions quite low. And I was at that time, 10 years ago, leading Estonian Nuclear Power Plant Association that was promoting the option of nuclear power. But now I've finished also my PhD studies on energy economics, especially on oil shale, and I'm going over to some of the details. I'm also happy to say that we already have some working staff. We have a member of very strong legal expert, Helen Cook from Australia, as our legal partner, and we have outstanding MOUs with several important partners. So looking at the big picture, if we want to achieve carbon neutrality in European Union, and that is the official policy, we need to close all solid fossil fuel. We need to close down all natural gas burning without carbon capture and storage, and also all oil in the transportation needs to be ended within 30 years. That is the policy. So that raises the question, where do you get the energy to replace those fossil fuels in both power generation, but also heating and transportation? Obviously, the answer to the transportation is electrification, but there is some role to hydrogen. So I did the numbers based on the primary energy generation statistics of EU, and looks, we need a lot of new nuclear, even if renewables are tripling from current generation. Yeah, but we have a problem with at hand. So we have nuclear energy utilities in Europe, but most of the utilities are government controlled. So they do have low independence on their actual policy. They need to follow the political demands, and also they have lower willingness to take risk. And unfortunately, also most utilities in EU are not interested in nuclear new build and do not have the motivation to challenge the EU renewables only, which also means gas burning mainstream. that Germany obviously is pursuing with great fanfare. And unfortunately also large nuclear, while there are countries in Central and Eastern Europe like Czech Republic and Poland and Bulgaria that want to pursue large nuclear, it is only deployable with substantial state support. Also the example from UK, where even state support in the case of Wilfa was not sufficient, and Hitachi pulled. And you have to recognize that nuclear deployment, from planning and siting, environmental impact assessment, development for the organization, for the construction and operation, and also the licensing is a long-term adventure. So and the problem also is that, but also its opportunity is that we have a massive loss of dispatchable capacities in Europe, in Northern Europe, in coming 5-6 years. As you know, unfortunately, Ringhals 1 will be closed end of this year. Ringhals 2 was closed already, so it means compared to 2018, loss of 13 terawatt hours of dispatchable capacity in Sweden. Norway is actively building major interconnections to Germany and UK. Denmark is building the Viking link to also to UK. Hansa Power Bridge would be exporting from SF4 to Germany by 2025. And Germany, as you know, is shutting down nuclear. And at the same time, they're shutting down coal, and also Netherlands is shutting down coal, and also Poland, because due to the aging of the coal units that were built in the 60s and 70s. So a lot of dispatchable power will be going away for good, but and the displacement will be intermittent power. And there is a problem with this intermittent power that you are aware of, that it is intermittent. This is real life hourly wind power generation in Estonia in 2018. We had 300 megawatts installed, but the median was 51. Statistically speaking, it's awful. And it's even when we have the half of the windmills in east of the country and half in the west, so 300 kilometers of a difference in east to west doesn't make a difference in balancing this flow. And from Estonian perspective, it says here that we, in Estonian language, there was a news last year that we lost 60% of the power generation reduction in Estonia was 60% from oil shale because of the CO2 prices. When we look at the European electricity map, then Estonia still is has the highest carbon intensity in power generation, because it is still half or majority based on oil shale, which is even more carbon intensive than coal or lignite. And looking at today's power market average, then you can see that the prices right today are one of the highest in Northern Europe. Only place where there is higher pricing is in UK. This means that, and the next numbers show that Baltics, but also Finland, is in power deficit and is currently being supplied by Sweden, but also by Russia and Belarus. So Lithuania and Latvia and Estonia have decided that already in November, when Astravets nuclear power plant comes online in Belarus, that we will close the power connection to Belarus. Because the Lithuanians are not extremely pleased that Astravets nuclear power plant will be located only 50 kilometers from their capital Vilnius. And at the same time, we have a policy in place of desynchronization from Russian grid system to European continental power system means that also imports from Russia, meaning from Kaliningrad or the continental Russia, will end by end of 2025. So it will have a significant impact on the power market, meaning that if you look at this schedule, the lower one where we are importing, the Baltics as a general are importing the imports that were last year from Russia and Belarus, they need to be almost replaced by imports from Finland and Sweden, which begs the obvious question whether those supplies are available 8,670 hours a year. And what is happening at the same time with existing capacities is that the CO2 prices are rising. Yesterday, the Parliament decided for 60% reduction target by 2030. It had immediate price impact already yesterday. So I think that the realistic is to see that already in 5 years we'll have CO2 prices 35. In 2030, it will be above 40, and it needs to go higher for two important reasons. One, you cannot make carbon capture and storage economical at lower carbon cost than 60-70 euros per ton. And you also, the second reason is what has been pointed out by BNP Paribas. You cannot make green hydrogen, which is all the hype in Europe right now, economical if the CO2 price is below 80. So the CO2 price has to move high already before 2040 for those investments to take place to achieve carbon neutrality in 2050. So those timescales that we are talking about are extremely aggressive. We should be actually building new nuclear power plants now to meet those targets realistically. So looking, and here above we have our hope of the outlook of having by 2040 10 terawatt hours of nuclear power generation, and then it is possible to achieve meaningful low carbon strategy for the Baltic countries. And this at a strategy where scenario when power demand increase are very modest. And this here I borrow a picture from our Finnish partners Fortum that shows their projections on how the Nordic power demand would increase when we would have significant carbon reduction targets in both heating, transportation, and the industry. So it is very substantial quantities of power that must be available 8,760 hours a year, which is a significant challenge. So I spoke already about the carbon pricing. And there are obvious limitations, in my view, on intermittent renewables. So the real life average wind capacity factor in European Union was 26. This is real life, not the best in the class. And with PVs in the north where we are, the real life capacity factor is 10. In Spain, it's 20. And it's very difficult to make sun shine in the night. So these are objective physical factors. And so I believe that there is a significant market potential to deploy small modular reactors, which in itself requires a lot of new development projects. I mean, that need to start in many locations, many countries, for there to be at all potential to deploy these wonderful technologies that Janne is developing. So from Estonian perspective, we are looking at technologies that are already in licensing or have high technological maturity. So Open 100 is a simple PVR that is the one like Ringholes 1 or 2 and 2. So second generation pressurized water system, with the recognition that actually when we look at the second generation units, they are perfectly safe. They are really, really safe. So, okay, but the problem with Open 100 is that it officially, at least, it is not yet in the licensing. So what is most near term in our view and commercially attractive and based on a real life experience, and by the way includes Swedish engineering in the form of contribution by Christer Dahlgren, is GE Hitachi design of boiling water reactor X300. Which is based on the ESP-WR that has been licensed with NRC in 2015. And there is a great momentum I see and I know behind its commercial deployment in Northern America. So what is our approach in Estonia? We are privately funded. We have raised funds from Estonia, and with simple recognition also that we don't have nuclear power capability and in Estonia, the question is what is the alternative? And there really is no strong alternative. So we have to pursue it. We are developing know-how about SMRs and the business case with institutional investors. We are seeking site agreements with municipalities. We have great progress there. I won't go into details, but that this is takes care of. So we make a value proposition to the municipalities that helps to remedy this NIMBY factor. And then we are able to move to National Spatial Planning Procedure, which is based on existing Estonian planning law. And we're developing a partnership with pro-nuclear, pro-climate utilities like Fortum and Vattenfall, and cooperating in specific areas. With Fortum, we have an excellent cooperation on licensing model, and discussing that licensing model later this year also with Finnish regulator. And we have mutually beneficial cooperation with select vendors that we believe are credible and take the deployment of the technology seriously. And we seek to be the licensee, owner, and operator of SMRs in Estonia. We're taking the same path as Fennovoima in Finland, but in little bit different setting and definitely without any Russian capital. Which is no-go in Estonia at least. So we have done some studies in 2019 that are published, but this year we are doing site screening studies with Tractable from Belgium, construction time study with Vattenfall, SMR licensing with Fortum. We have studied in detail industrial steam generation from light water system at 200 degrees Celsius, not extremely high temperature steam, but for pulp plant, wood pulp plant, 200 C is totally sufficient. District heat supply in 20-kilometer radius. And we're also studying a little bit, not too closely, but a little bit also domestic supply chain. So we have agreed this week to study deep isolation deployment in Estonian geology. And for you, those who don't know about geology, actually the Baltic Shield or the Fennoscandian Shield, Proterozoic, it extends to Estonia as well. So if you have final repositories in Sweden and in Olkiluoto, Onkalo, we have pretty much the same geology. So this is our time schedule, like Elon time schedule, that quite the optimistic and aggressive one, to fundamentally, if the first of a kind would be critical, United States or Canada, then we would be ready with our regulatory development, planning procedures, organizational development and the regulatory development, so that we would be able to apply immediately following the first of a kind criticality for the license and receive the license within 12 months and then proceed to construction. It is not possible, in our view, to be more aggressive. And we are also trying to cooperate with other companies, organizations that are taking seriously SMR development. So we founded before our annual conference early this year in Tallinn, SMR Alliance, which is SMR consortia from UK, Nuclear Ireland, and Synthos Green Energy, and new member is Nuclear Reactors from Romania, organization to organize similar webinars like we are having now to discuss the deployment business and real life challenges that we have. We have had great webinars on licensing, communications. We'll be having soon on financing, and eventually, as you know, with all reactor types, there are there is a pressurized water reactors operators group, condo operators group, and so forth. I believe there in the future there needs to be a SMR operators group. So that is about our presentation. So our work, and we are working every day towards to execute to have SMR deployment of hopefully 3 to 4 units in the 30s in Estonia. And then if we are successful in that, doing at the same time, we believe that it is great market for us based on our experience and relationships and know-how and ability to grow the team to look at other markets that are open for new nuclear. Thank you.
Thank you very much, Kalev, for that very interesting talk. It's very exciting to see this new market in Estonia. And I have one question. Could you talk a little bit about the political response and the public opinion in Estonia regarding this nuclear ambitions?
Thank you. That is a very important question. Indeed, we started measuring the public perception immediately when we started early last year. And to our surprise, we asked the question from the public in the survey from 1,000 people. Like now, we have measured that 4 times, with different companies, but the same question: Are you willing? Do you agree that we need to consider a small modular reactor deployment to replace oil shale power generation? And in the beginning of last year, the answer was 52% said yes, or rather yes. End of last year, it was 56%, and early this year it was 58%, and again this September the result was 58% yes, or rather yes. I think for such a challenging thing in a new country, it would be overly optimistic to have look for a better answer. I mean, do have a 60, more like 66% yes. I mean, there are very few questions that reach this kind of social unanimity. And there is an increasing awareness definitely in Estonia about the climate change. There are increasing understanding that the policies need to be in place. Estonia has formally joined the pledge of carbon neutrality in European Union. And now to the government policies, indeed, as you know, we have the virus emergency situation, but the ministries developed during the emergency area even a memorandum that would seek to establish nuclear energy committee by the government that would develop formal understanding that if and whether the SMRs really are the credible choice for Estonia, and what the government would need to do for make their deployment possible. So, and we are having regular meetings with decision makers, both officials and politicians, and the public engagement is also active. So we're doing during the crisis emergency area, we did 20 public lectures in schools virtually, and we have continued to do so every week. So yeah, we're doing quite active work. So and stand-up for nuclear in Estonia took place not in one town but in 2 towns. So try to overdo that in Sverige.
Okay, thank you. Yes, we did. We had a small stand-up in Malmö in September. The society was part of that organization. Regarding the shutdown of the oil shale, when is that due to take place, and what is the official strategy? I mean, the government must have a strategy for phasing out the oil shale, and how does it?
There is no fixed date there, but the market forces and especially CO2 pricing will do its job very effectively. Like I showed you, there was a 60% reduction from 11 terawatt hours to 6 terawatt hours year on year. So if the CO2 price moves to 30, 35, the reductions, but then you have to have the balance, you know. If you don't have the power supply from somewhere else, then this is the marginal supplier, and then it sets the market price. And I can see that for many hours still in late 2020s, when we don't have the nuclear power plant, oil shale power generation will be at least with 300 megawatts or something like that will be online because there is no sufficient capacity to displace it, especially at the same time we're closing the supplies from Russia and Belarus. So it's a tricky situation.
Okay, so you're saying that there are no, from the government point of view, it's not a hard decisions that are shaping this future. It's they are relying on market forces to take care of this transition. Yeah, and there is particularly this area where the mining takes place that has been this oil shale mining area historically for 100 years, and there are some social issues also related. But so I don't think that it is likely. There are some parties in Estonia, Social Democrats, who strongly advise to favor to have 2030 fixed timeline when oil shale utilization will stop. But I think it remains minority view. But the carbon pricing will be very effective. Okay, is there anyone from the audience that has a question? Okay, we have here Paolo.
Yes, hello everybody. This is Paolo Ferroni from Westinghouse. Thank you very much for the presentation, both Janne and Kalev. I have a question for Kalev regarding an LCOE range that you showed in one of your slides, between 30 and 40 euro per megawatt hour. I was wondering if that range is a goal, or if it is a range that you think the technologies that you showed can actually achieve.
Yes, I believe this is the range that nth of a kind can achieve. Because if you look at X300, it's the simplest nuclear steam system that is possible to envision. It is simpler than Forsmark units. It's simpler than ABWRs by far. It is per megawatt even 2 times less concrete compared to ABWR. And if you really know about nuclear economics, then you know that it's less about steel than about the concrete, because concrete just takes a lot of time and a lot of man hours to lay the reinforcement. And if you have been to Olkiluoto, you have seen the nuclear reinforcement, what it really means. So that's quite a thing. So I do believe, and knowing a lot of details about X300, that is realistic.
Okay, yeah, thank you. Yeah, the main reason for my question is somehow related to also what Janne said earlier, the fact that SMRs don't, let's say, the economy of scale is not in their favor. And so the communities basically rely on the fact that modularization can be achieved, which is something that I definitely hope, but nobody has proven it yet.
Yes, before Elon Musk started working on electrical vehicles, also no one had proven that electrical vehicles will be a thing.
Yeah.
Okay, anyone else? Okay, we have Balder, please.
Yeah, hi. Thank you for the lovely presentation. I would like to know if there is any other initiatives in Estonia in regards to, I don't know, renewables with storage techniques or biogas, etc., that might, compete with this initiative, or is small modular reactors the way to go, or is that the direction of Estonia now?
Of course, there's competition, and the most we have 300 megawatts in wind installed now. There is one wind park that hopes to get subsidies from the government for 140 megawatts, but so it is not decisive. There are several wind offshore developments, but they all require subsidies. Especially they require subsidies for the interconnections from offshore to the shore. And even if the wind capacity factors offshore are 45 something, it's still not 8,760 hours a year. So, but we need every second 8,760 hours a year. So we are not. I'm not extremely concerned about wind installments, because also looking at the grid size, while there are about 3 or 4 offshore wind developments offshore in Estonia, actually only one of them can get the connection to the shore substation, because otherwise the western link between Estonia and Latvia will be overflooded, and so they are mutually exclusive.
Okay, thank you very much.
Okay, we have a question from Mats.
Yeah, sorry. Hello, Mats Ladeborn, Vattenfall. Thank you very much, Jan and Kalle, for very good presentations. Just a question, Kalle. You mentioned that you think that the market will actually solve the issue in Estonia for building new power production. But of course, many countries has tried this, and UK is the best example, of course, to see that the market might not solve this issue. So don't you think there will be any discussions regarding, I would say not subsidies, but some, I would say, support system from the government in order to fix the infrastructure and the new production capacity?
That is now quite a serious question, Mats, of course. We discussed that today or yesterday at the International Atomic Energy Agency contracting and technical working group discussion about UK situation. And George Borovas from Shearman correctly said that and I know some insights also about Hitachi pullout from Wilfa, is that what the UK government tried to do was to offload all of the nuclear deployment risk to the deployer. And the same thing happens with PPP projects also in infrastructure construction, in large infrastructure buildings like high-speed railways and some other projects. If you try to do that, offload all the risk, where actually the primary source of risk is the regulator or the permitting, then you end up in a solution where the private contractor has to raise the cost and the interest cost of the debt so high that it makes it, in fact, uncompetitive. And that is exactly what happened. UK has its own also peculiar problem. The pre-funded decommissioning program that is in UK, I know some insights out of that. This is extremely expensive and needs to be revised, really reformed before there is a new builds in there. Third element, I don't know really how it is possible that the EDF has pulled the pants down on UK government on the cost of weighted average cost of capital in Hinkley Point C. But having this level of weighted average cost of capital, 9% and 60% of the total capital cost of the plant new build being interest during construction and post-construction, obviously is totally unfeasible. And here the size of the new build really matters. A lot of the actual reduction in the cost of renewables windmill, which is totally commendable, but really has been achieved due to the reduction of the cost of capital for renewable builds. So the green capital movement or green bonds movement and capital movement into renewables has reduced the capital cost of the total levelized cost of electricity of the renewables. So this is the area where I believe where we need the governments to step in and where I don't think that there should be any kind of subsidy on nuclear on power generation basis. But what I think is fundamentally relevant is that governments are willing to lend, at least during construction, to reduce the capital cost part of the construction. And here we also see good progress in Estonia, not necessarily regarding nuclear, but other developments that green financing, understanding that government needs to step in to help lending to do major infrastructure projects, also privately funded, is something to do. So I hope I answered your question.
Yeah, thank you, Kalle. It's not an easy question, but I think you elaborated very well on the topic. So thank you very much.
Okay, next question from Janne.
Yes, hello, Caleb. Thank you for an interesting presentation. My question is about the potential for providing process heat to the Estonian paper industry. Have you been able to conduct such a discussion with actual paper mills?
Of course, we don't have a paper mill, but we have a major wood pulp facility in Kunda, which is our likely site, which is just 1,000 meters away from our potential site. And we did the calculation that the challenge there is that our location is 5 meters from the sea level, but it's up the hill like 45 meters. So we need to push the steam up the hill, and yeah, they require low temperature steam, and we are having extensive discussion with this industry. They want to build a second line or second facility, so they would increase actually the consumption of steam. And currently they are by far the largest net power consumer in Estonia and largest net natural gas consumer in Estonia. So yeah, they are. The only problem with them is that their owners are Austrians.
Okay. Thank you very much for this information.
Do we have any more questions? You can also ask questions to Janne if you have. Okay, it doesn't look like that. We are coming to the end of our webinar, and before we do that, I can ask one final question for Kalev. Now, we have heard about your goals, some ambitious goals, and what do you see? There are one can visualize many challenges, but what do you think are the main challenges that you are facing to say, let's say, realize a first SMR in Estonia by 2030 or something like that?
Yeah, thank you for the question. So I think the main challenge is the complexity of it. So I've answered that question many times that has been put forward in Estonia, that there is no single one. Technology is not the challenge. I do believe that, frankly. I don't believe that construction fundamentally is the challenge. We can handle that. Also politics. We can handle that. We know the people we need to talk with. We know the public perception that is an also issue that I believe it is. We go to every school, we talk to all the people. We do that, and also we don't have enemies in Estonia, which is quite positive. Like strong enemies. There are nice enemies that we have. So, but what is and whether it is possible to finance the activities, I think there are challenges, but can be overcome. Whether licensing is the fundamental challenge or developing the regulation, I don't know. I don't think that is the main one. What is the problem is that you need to have so many things going right at the same time. That is the challenge. That is, and they are interrelated. So here we have, this is also the fundamental challenge of nuclear energy, but also that makes the thing fun, right? So the greater the challenge, the greater the, how to say, encouragement and persistence you need as an individual and as a team. And so I think that the fundamental, we always arrive at the same question: what is the alternative? And if you can't answer that, I mean, then you need to pursue what we are doing.
Okay, so you say that the main challenge is the complexity of having these many activities working in parallel that have to interact and going forward.
Yeah, executing all of those elements at the same time very professionally and doing a lot of work.
Which is a little bit of an irony because the SMR is supposed to be simpler.
Yes, it is definitely simpler than doing a 7 billion euro investment at the same go. Definitely requires that would be impossible in Estonia. That magnitude of project, that magnitude of capital, and we see that challenge also in Poland that they face that when it comes really having that capability. That amount of people, that amount of capital, that amount of things going right, where you are narrowing down your supply chain to large-scale units, and it is just even it's like going to the Mars without stopping by at the moon.
Good comparison. Okay, we have one final question by Antanas Romas. Please, Antanas.
Thank you very much for the nice presentation. And my question is just a continuation of previous question. And it sounds like that. If you would personally evaluate between 1 to 10, what is the chance that your project will not end up in the same way as the Visaginas project in Lithuania?
Oh yeah, Visaginas project has given a lot of very good lessons, and one important lesson is to we have been talking also to Estonian politicians that look, if you believe that this is an area for infighting, forget about it. Let's not do anything. Let's continue importing from somewhere where there is no supplies available. That was the thing that happened in Lithuania, where the government believed that they can solve their political problems with referenda. And I mean, David Cameron was one of the leaders, well-known leaders, who believed that that can be solved also, internal political problems with the referenda. There is no good, very good practical experience in Europe where referenda is the solution to internal political problems. Second, we are not going for large water system, large reactor system. That also was a fundamental problem. And third element, I strongly believe in regional cooperation. Lithuanian project, we know from reality, they were very bad and continued to be very bad in regional cooperation. Here I hope that we are a bit better.
Okay, so the point would be 0 risk.
No, there is definite risk, but I think the likelihood of success is 60%.
Okay, thank you.
Okay, it's 2 o'clock, and we have reached the end of this webinar. I thank you very much for all your participation, and especially from the presenters, Janne and Carlo. Thank you very much for showing up and giving us the latest news on your both very exciting projects. Okay, we end here, and please remember, we will put up the material on our website, and there will be more interesting webinars coming in the near future. Thank you very much, and have a good weekend.
Thank you very much. Bye-bye.
Thank you very much, guys. Good to see you.